Okay, so for my second exam question with the vectors, this is my work. So my student ID is 107824006. And so the third digit is 7, the sixth digit is 4, and then my final digit is between 5 and 9, so I go 30 degrees south. My seventh digit is from 0 to 4, so it's the plus 90 degrees. So my second vector will be at the 150 degrees. And so I drew it on a graph. My two vectors are the 7 at the negative 30 and the 4 at the 150, or the 30 from north from the negative x. And so from looking at it, you can tell that since they're going in opposite directions, that the magnitude of the combination of the two of them is going to be 3 at negative 30 from north. But I thought I would just do the math because that's the point. So, and this is negative 30 from north, or from positive x, or positive x. Anyway, so the first thing we have to do is the components of each vector. And so I've got my Vy and Vx's for both of them. And so it's, this is for my A vector. And so it's 7 sine of angle theta, and then 7 cosine of angle theta for the x component. And so you do both of those, and it's really nice for the sine because it's just 0.5. And I did positive values for all my angles just to make it easier, and then I just remembered to add the negative in. But so the 7 sine 30 is times 0.5, so it's 3.5, and then in the negative direction because it's that negative y. And then so the 7 cosine, this one stays in the positive direction, so it's 7 cosine, which isn't as fun as sine 30, and you get this value. And I took it out super far because I wanted it to be accurate when I did my final calculation. And I did that the same for the x component of the 4 vector as well. But so then I did the same calculations again for the second vector. And so it's 4 sine of theta, which is 4 sine 30, which is 2. 4 cosine theta, which is 4 cosine 30, which was 3.46. I switched it to negative because it's a negative x value. And then I took this one out super far to get a more accurate number for my final number as well. And then so I combined the components together. And so the negative 3.5 and 2 is a negative 1.5 y value. And then the x magnitude of x components combined, added up. I didn't write the numbers again, but together these two numbers equal 2.598. And then I just used Pythagorean theorem to get the total magnitude of that vector. And so it's the square root of a squared plus b squared, so I squared 1.5, squared the 2.598, and then it's 2.25, and then 6.7499. And then when you square root those two numbers after adding them, you get 2.9 repeating. And so that's basically 3 for my magnitude. And then I wanted to do angle, and so theta we wanted to find out, and so I just did the tangent theta equation, or trigonometric rule, I don't know. But so tan theta equals opposite over adjacent, and then theta equals inverse tan of opposite over adjacent, and then theta equals inverse tan of 1.5 over 2.598, and then theta equals 30.001 degrees. And so my final answer, my a plus b vectors combined, are 2.9 repeating at 30 degrees.